In this tutorial, we will take a look at how we can examine 3D images in Planmeca Romexis software. So we'll go through how we can adjust images, how we can navigate in them, how we can annotate the images, and how we can save findings, among other things. So there's a separate tutorial for working with the 3D imaging module. So here in this tutorial, let's focus on examining the 3D images, and let's go directly here and open CBCT volume. So the volume gets opened here in Explorer submodule, and in this tutorial we will basically remain here in this submodule and see how we can work on the images here. And other submodules are then covered in separate tutorials. So firstly, let's take a look at what we can see here. Here on the right, we have a toolbar for adjusting the images. We will go through many of the functions here in this tutorial. And then here we have the image data. So here we have 3D rendered view of the data. And working with this will be also covered in a separate tutorial. But let's just activate the planes so that we can understand better from where these different views are taken. So we can see with color indication that, for example, the sagittal slice is here in the volume currently, and then we have this coronal slice here, and finally axial here. So and also in the other views we can see the respective planes of the other views. So for example, axial goes currently here, and so on. So the colors can help us in understanding where we are in the data. And we can adjust this layout a little bit. So for example, if you would like to see this coronal view bigger, we can maximize it. So each of these views have some controls next to them, so we could use this first button here for maximizing the coronal view on the whole space available for viewing the images. Or then we can minimize it back. And furthermore, we can also determine how many slices of this coronal view, for example, we would be viewing simultaneously. So if I open the Viewport Settings, so again these controls that we have here next to the view, I can see a grid, and here if I hover my mouse on top of this grid, I can determine what is the layout and what is the number of the slices that we would be viewing simultaneously. So once when I have my preferred selection highlighted here in the grid, I can just click with my left mouse button, and now we see that we have 4 coronal slices simultaneously visible. And we can also see in the other views from where these slices are taken. We can also adjust what is the distance between the slices. So if we open again the Viewport Settings here, here we have a control for adjusting the distance between separate slices. So let's change this back to 1 slice. And also, if we would like to mirror the data, so for example, if we would like to view this sagittal view mirrored, this other button here helps us. So this mirrors the data. Let's then take a look at how we can change slice thickness. So here in the toolbar, the first button allows us to open a drop-down menu of available slice thicknesses. So for example, if we select here a thick slice thickness, that will be applied to all of these views simultaneously. And so now when we have a thick slice, we have lots of information, but the view gets a little bit blurry because of all the information in that. Or then we could change it to very thin slice that looks sharper but doesn't have that much information in it. And because this control here changes the slice thickness for all of the views, but if we would like to adjust individually the slice thickness in one of these views, we can again open the Viewport Settings and here we have a control for adjusting the slice thickness specifically for this sagittal slice here. And if we always would prefer having some specific slice thickness for the different views, we could save our setting here through the default settings. So this big wrench-like icon here in the toolbar, and here we could specify the slice thickness and distance between separate slices and the number of slices. So this is how we would always view all the captured images, all the new images that we would be taking with this workstation. That's how they would be opened by default. And we can view the relative tissue density on each view by hovering our mouse on top of that. So here on the lower right corner we can see the HU Hounsfield unit value of that point where our cursor is on the view. Then let's see how we can adjust the grayscale values of these images. So firstly here in the toolbar we have these 3 simple sliders for adjusting the contrast, brightness and sharpness of the slices. So these get applied simultaneously to all of these views. And additionally we have also a histogram available. So it's this function that's called adjust levels. So if we open that we can see all the grayscale values in the image, and here we can determine which all values are visible on the images, and then we could adjust by using the gamma here. And furthermore, one more thing for adjusting the images, there's noise filter also available. So if we would like to remove some noise from the images, we could use the function here. Take a look at more information in the user's manual. Let's move on to navigating in the images. So firstly, each of the views has this slider next to them. So if we just grab the slider and move it, we see that we can move in the data. So the sagittal plane gets moved through the volume. And also if we would like to move with smaller steps, so frame by frame, we can use the arrow on one of the ends of the slider. So this allows us to examine still more accurately the volume. And then here, considering the navigation into data, here we have 2 functions that are essential in the navigation. So firstly, when this first one, zooming, is active, we can use our mouse wheel on top of any of these views, and we can zoom in and out the view. But instead, when we deactivate this toggle zoom here, and now we use our mouse wheel on top of the view, we see that we can actually navigate through the data, just like we did with the slider. And this other function lets us determine if we want to navigate inside the data by moving the volume itself, or if we want to move the cross-sectional planes instead and look for areas of interest in the volume. So firstly, when this is active, we can grab on any of these views. We can grab with the mouse the volume, and we can move the volume so that we have our area of interest in the volume here on the focus of the planes. And so we can move with left mouse button, and with right mouse button we can rotate the volume. So this way we can generate the kind of view that we would be interested in. And like I said, another option is to move these cross sections instead. So if we deactivate this move rotate volume, we can actually grab the cross section of the planes, and we can click that to any point of interest in the volume, or or we can just move it around. And respectively, also this cross-section of the planes we can rotate with the right mouse button. So left mouse button for moving, right mouse button for rotating. So this way we can generate the kind of views where we have the anatomy that we are interested in the focus. And now, for example, if we would like to move the volume around this cross-section here, and if we activate this Move Rotate Volume again and rotate with the right mouse button, we see that it doesn't get rotated according to this point where the cross-sectional planes meet, but instead it gets rotated according to the center point of the view. But we can change that again from the default settings. So if we open the default settings, the wrench-like icon here, we can select this rotate volume around cross, and now that that's selected, now instead the volume gets rotated according to the point here. And if you would prefer to use both of these buttons and both of the modes for each buttons when you're navigating into data, we actually also have keyboard shortcuts for these functions and for some other functions here in the toolbar as well. So you can see the Romexis user's manual in order to see the full list of different keyboard shortcuts. So we don't always need to come here and activate and deactivate them with the mouse. And then just mentioning shortly this export view to other tabs. So because the other sub-modules, the tabs, don't necessarily have, for example, the coronal view, but if we would like to adjust the coronal orientation here and use that same orientation in other sub-modules, we can just simply click here. Let's then take a look at how we can reset the view. So for example, if it happened that we managed to move the volume completely out of the image viewing area, we can get it back. So there are basically two ways to do that. So here in the toolbar we have this reset orientation. So this resets the volume orientation where it was after capturing or importing the image. And then there's one more function here in the upper toolbar. So here we have reset view. So this reset view both resets the orientation and also cancels all the adjustments that we made to the image. And if we would like to view only the raw data and we would like to get rid of these overlays that we have here to help us with the data, we can hide the overlay by using this annotation overlay button. So now we got rid of all the overlays. And if we wouldn't like to get rid of all of them simultaneously, but we would like to determine which of them would be disappearing, we can open this default settings. So again, this big wrench-like icon here. So here we can open this, and here we can select one by one what everything we will have visible. So for example, now I hit the actual line here from the other views. Now I could hide also the coronal line and so on. I'll put them back. And let's close this. Let's then see how we can annotate these images. So firstly, if we navigate to some tools of interest here into data, so here we could use these annotation tools in order to make any highlights on the images and measure lengths and draw something on the images. So firstly here we have some measurement tools and then some tools for highlighting something on the images. So for example, if we activate here the measure length, I could just simply track with my mouse the length on top of this tooth, and here I have selected in default settings, so this icon here, an option that allows me to place this measurement label manually. So now it stays here attached to my mouse cursor until I click somewhere in order to attach the label there. And if I would click here on the lower right corner of the icon, I could have several options. So I could also measure a polyline instead of single line. And then I could measure angles. I could add text and arrow to images. So if I have this activated, I can just click on the image and I can write my note there. And we can also draw rectangles and ellipses. So for example, if I draw an ellipse here, this now, in addition to the dimensions of the ellipse, it actually also gives me the average HU value on this area. In addition to these, we can also make three-dimensional objects here, so we could measure cubes and ellipsoids also, but let's cover that in the tutorial that is about segmentations in 3D imaging module. And then something about these annotations here. So if we now navigate into data and now we start wondering where are our annotations, we can find them here in the object browser. So these work as links. So if we would like to find any of these annotations, we can just simply click on them in the object browser and we will be brought back to that slice where we made the annotations initially. So we never lose them, or we don't need to look for them by browsing through the data. And now that we started talking about the object browser, let's take a closer look at that. So object browser is the function where we can manage the different objects that we have added to the data. So here, like we see, we can see different objects grouped under separate categories. So here we can manage annotations, nerves, fitted models, implant guides. We can save views. Let's go back to that later. And then we have even a proface that happens to be hidden at the moment. So here let's see how we can manage the objects here. So firstly, where we see the eye icon, we can click on that and we can hide all the objects in that group. So for example, I could hide all the annotations or the nerve and make them visible again. And furthermore, I can change color also. So if I would select here, for example, this length measurement, I could determine some other color for that. And now we see that we got a new color. And if we always prefer to have our annotations in some specific color, again, in default settings, we can determine that. So if we open the default settings and go to this general tab here, here I can specify what are my preferred colors for different types of annotations. And here I can, by the way, also determine what are my preferred image adjustments for all the new images captured on this workstation. And Object Browser allows us also to simply delete annotations. So if I, for example, get rid of this whole group of annotations, I could activate the whole group by ticking this box here, or then I could select here single annotations by ticking the respective box here, and then I can select this trash can icon here. And I need to make sure that I always select the trash can icon that is related to this group. So otherwise it wouldn't work. So I need to select the objects that I want to delete and then use this. And Romexis will still ask for confirmation. So now I got rid of my annotations. And here in the Object Browser we have also some other functionality depending on what objects we have here. So for example, for fitted models and also for implants and some other types of objects, we have this lock icon, so we can lock the objects so that we wouldn't accidentally move them in the plan. And also if we have this wrench icon here, that means that we can somehow adjust the object. Let's then take a look at how we can save findings that we make here in the volume. So firstly, if we would like to go back to some specific place in the volume later, so if we find something interesting somewhere in the volume and we want to find that place later, naturally, like I said, we could make some annotation and we could go back to this view by clicking on the annotation here, but we can actually also just save this position here. So if we go to upper toolbar, we can select here Save View, and now we could give our view a name. So it could be, for example, tooth number or the name of the finding that we made. And now if we would browse further in the data and would like to go back to that view again, we can again just simply click here on the view and it brings us to that place. Then naturally we can also make 2D snapshots. So these 3D views that we save here, naturally we can go back to them only here or in the Romexis viewer if we would export this volume with the Romexis viewer. But if we would like to make 2D snapshots of the view and, for example, generate a printout of them, we could use this Save 2D view in the upper toolbar. So here we could firstly determine which all views would be taken along in the snapshot, and if we want to exclude any of these views, we can click on them and determine which of the views would be included. And through this multi-panel division option, we can also specify more exactly how is the layout of the different views. And through this we could have, for example, more slices available for each views, more than what we have here through the Viewport Settings option. And furthermore, we can specify whether we want to generate colored snapshots. So if we have this option selected, it generates us 8-bit colored images, or then if we deselect it, now we would save these to 2D imaging module as 12-bit grayscale images. So if we want to process them further in the 2D imaging module, maybe we save them as grayscale, as non-colored snapshots. And then we can determine whether we create one single image or separate images, so each view gets saved as a separate image. And then with Generate Images as shown, we can make sure that, for example, the zoom level and everything is in the snapshots just like we see them here on the screen. And high resolution makes the resolution higher. So, for example, the labels on the images don't look that blurry. And then we can also make the font size larger. And if we always prefer to use some specific selection of these presets, we could save them as default so that they are always pre-selected. So let's then try saving a 2D image. So now that I selected all of the views to be saved as one single snapshot, and like we saw, this 2D snapshot got automatically saved here in the 2D imaging module for the same patient. So this is a practical way for recording the findings made in the 3D imaging module directly to 2D module. But let's go back to 3D. Another way to take snapshots quickly is to use this camera icon here next to each view. So if we click here, a snapshot of just this view got saved to 2D imaging module. So let's go there, and now we see that we have this axial snapshot here saved as a single view. So naturally, those snapshots that we save to the 2D imaging module, we can then process further with the tools available in 2D imaging module. And finally, we could also save a stack of 2D snapshots by using this reslicer tool here. So it was this icon here on the toolbar. So here we could determine what would be the view where we would like to mark the area from where the snapshots are generated, and then we could just simply, with this tool active, we could draw the area from which the snapshots are generated, and then I can deactivate that with the right mouse button. And now here we see the stack of images that we would be saving. So now I could save that to 2D imaging module, or then I could send that directly to storage. So this stack of images, and I can also determine if I want to include this source view here as well, so that we understand the area from where these images were taken. Let's cancel this this time. Finally, in order to save findings, we could also write the diagnosis for the image. So if we go here to the upper toolbar, I can open image properties, and here I have a diagnosis tab. So this is where I could write diagnosis for the image. So if I would like to save that here in the 3D module related to the 3D image.